All right, hey everyone. We have a student from Austin, Texas. UT Austin solved around 150 lead code questions. So, what year are you in university?
Yeah, what's up? I'm a junior.
Junior? So, third year?
Yeah, yeah.
So, how are you at lead code?
Um, I started this summer.
Nice.
Yeah, and I'd say I'm not that good. I'm keep I'm trying to practice more and more.
Yeah. So, what concepts can I ask you? Are you good with? How are you with trees and graphs?
Yeah, I'm comfortable with those.
Nice. What about arrays?
Yeah, that's fine too.
Nice. So, what kind of jobs are you looking to land?
Mostly like SWE or ML data
Nice.
science, like look at everything.
Yeah. Are you having trouble getting interviews or no?
Yeah, kind of. I applied to like maybe like 200
200?
and didn't get any. Yeah, I didn't get any interviews yet.
Okay, that's quite a lot, but I'm sure you'll start getting some because you're in your third year. You'll be
Yeah, I
good.
hope so.
Do you care where it's gonna be, or you're applying anywhere and everywhere?
Yeah, anywhere, remote,
Nice.
you like any city.
So, what companies did you apply for? Are all the companies out now? I haven't even checked, so I don't know like who's hiring or.
Uh, yeah, most like FANG companies are already out. Like all the unicorns, Notion, LinkedIn, Databricks, they're all out.
Nice,
Yeah, I don't know what other companies are there left.
nice. So you applied for all the fangs, all the unicorns, everything.
Yeah.
Nice. And what's sort of the process that for all those companies this year?
Uh, so just the application, then there's often an OA. I had an
Yep.
OA for Google, and I'm still like waiting for them to reach back.
Hmm.
Yeah, but I didn't get anything else from other companies.
So all companies are pretty much still asking leak code these days. That's still the process.
I believe so, yeah.
I see. Cool. All right. Let's hop into this interview then. We're gonna be working through 1 to 2 questions. We're gonna spend about 20 minutes per question. So
Okay.
yeah, let's see how you perform.
Okay.
So I'm gonna give you the first question. What language do you like to use?
Python.
Python. All right. All right. This is the first question. We're gonna be given an undirected tree consisting of n vertices numbered from 0 to n minus 1. Each Some of the vertices have apples, and we need to return the amount of time it takes to collect all the apples in this tree. So that's what the question is at a high level. I'll let you go ahead and read the question. There's a lot to it, so just take your time and let me know if you have any questions.
Okay. Yeah. So it's undirected tree and vertices. Some have apples, some don't. 1 second to walk from over one edge.
Yep.
And we need minimum time in seconds to spend collect all apples in trees. Timer is zero and come back to this vertex. Okay, so we have to come back. Okay, and the edges are undirected. So given AI, BI, there's an existing edge connecting versus AI. Addition, there is a Boolean array as apples, where as apple I equals true means the vertex I has an apple, otherwise it doesn't have any apple. Okay, so we have to also come back. Interesting. Okay, and are there like any examples, or I have to come up with my own?
I'll give you one example.
Okay.
So here's one of the examples.
Hmm.
So there's also a drawing if you want to draw it out. I'll post the example in the drawing, or yeah, in the drawing mode, the whiteboard.
Oh yeah, I see. Did you paste the drawing?
Oh, you don't see it? It's in there.
Like I
Maybe.
see input, output.
Yeah, that's pretty much the input. So I mean, I can draw it out for you.
Oh,
I can draw it
oh
out for you
no,
if you
no,
want.
it's
Okay.
chill, it's chill. I can do it.
Yeah. So these are the edges. So edge. So the first element shows that there's an edge from 0 to 1, and then there's an edge
Okay,
from 0 to 2, then an
okay,
edge from 1 to 4. So draw it out, and like you can color each node that has an apple with a green, and then we'll figure out from there why the output equals 8.
okay. So we have
Yo,
no.
MX was good.
Oh, so hard. Okay, node 0. There's the edge to node 1. So there's also edge from 0 to 2.
Yeah, it's gonna be a tree, by the way.
Oh, okay.
If that changes
And
how you want to draw it, but it's fine.
yeah, lucky. I'm gonna redraw it real quick. So there is 1 to 4, 1 to 5. Two to 3, 2 to 6. And the edges, so which ones? 1 to 4 has an apple. So I'll just mark it like that.
Well, or no, it says like for each index here, that's a node. So this is node 0. Node 0 doesn't have an apple. Yeah, this
Oh,
is node 1, node 2.
yeah, my bad.
Yeah.
Okay, so
So here node 2 has an apple.
yeah, so I guess I'll just node 2 has 1 and node 4 and 5. Okay,
Exactly.
so we start with node 0. Then I guess we explore one of the paths. We go to node 1, check its children. So we have to collect 4 and 5. That's what. So we went from that's 3 sec. No, we also okay. So 0 to 1 is 1 second.
Yeah.
1 to 4 is one more second. I have to go back,
Yeah.
which is 3 seconds.
Yeah.
Then to 5 is so 4. Go back to 1 is 5. Go back
Yep.
to 0 is 6.
Mm-hmm.
Then go to 2, which is 7. Go back. Okay. Yeah, which gives you 8.
Yeah.
Interesting. And we are given it just an array of edges. Okay. We have to collect all the apples.
Yeah. Exactly.
Mhm. Mhm. Yeah, I guess it's some kind of like in-order traversal. Oh, but is it they want the minimum, right? Oh yeah, the minimum time. So if 4 didn't have any apples, then there would be no point in like wasting 2 seconds going
Yep.
there and back.
Exactly.
Okay. So I have to somehow determine if I should explore that path. Hmm.
Christian, what's up, man?
Okay.
Yep. Exactly.
Mhm. Yeah, I'm just trying to think. Yeah, and here, for example, when I was at 2, I knew that I'm done exploring all the apples, so there was no point in checking 3 and 6. I just went back. So I need to track all the apples that are collected.
Yeah. Exactly.
So
Christian,
probably I could store
congratulations
like
on
a
the Capital
variable
One internship.
of how many apples I've collected so far.
When do you
Um,
start?
and I also can find how many apples I need to collect. Okay. Mhm. Yeah. Yeah, I'm just trying to figure out like in the efficient way of checking whether there's any point in exploring particular children.
Makes sense.
Yeah. Yeah, I was also thinking maybe it would be easier to just like iterate over the apples I need over the nodes I need to visit. But that would make sense because if I like if I like go from 0 to 4, it gives me 4 seconds. But then that's not
Mm.
the minimum because like when exploring 4, it's easier to go back to 1 and then to 5. That will save me more seconds.
Yep.
Okay. So maybe some kind of backtracking, like if I say node 1 didn't have any children that have apples, so the left subtree of 0 is like just like useless for us. So maybe I could have went and explored it, but once I realized there are no apples, I could like backtrack and subtract the wasted seconds. Or it's some kind of recursion. Mhm.
Hey, what's up, man? Thanks for tuning in all the way from Mexico.
Do you have any hints on
Okay, so
like choosing the paths?
yeah, so what you're thinking right now is you don't want to. You're saying you don't want to explore a path because it might be a waste.
Yeah,
What would be an example of that? Would it be something like
like if like look at node 1
okay?
and
What
right
would be
now
the
it's like
answer to
4.
this?
Oh, okay.
Right. What would be the answer to this?
So we would just go from 0 to 4, which is 2 seconds, back to 1, 3 seconds, check 5, 4, and then go back to 0, which is 6.
Yep.
Yeah. And we never visited the right subtree of
Yep.
0.
Yeah, but we would probably have to visit the right subtree, right? Just to figure out if there's any apples in there.
Yeah, yeah, that's true.
Yeah. Okay. So you mentioned.
So
So what are the possible traversals that you could conduct on this binary tree or this tree? You mentioned one of them.
like in order, pre-order,
Yeah.
yeah. So you're
So
asking what type of traversal is like fits the most?
yeah, just try to think through the different traversals and try to see which one would fit the most for
Yeah,
this problem.
yeah. It looks like the in order traversal because we're like go left. Oh, wait, actually, if one had an apple too, then I would check if one had an apple and then go left and right. So it's pre-order.
Or let's see. Let's create a very sim. Let's create let's work with some smaller cases. Let's just do like zero here. Let's work with this small case right here. One, two, right? And let's just say
Mhm.
we only had this. How would you get the algorithm to work there?
Okay. Okay. So I mean, I started node zero. I check if node zero has an apple in my has apple array. If it does have an apple, I don't do anything basically because it's a it's a starting point. Then I check the left subtree, check one. One does have an apple. So but I also have to like add the second I spend traversing that. Then I would go back to zero and add one more second and then explore right. The two doesn't have an apple and it's a leaf node. So like I'm basically done traversing it and I would subtract the second that I added when visiting it, right?
Hmm.
Am I thinking of it in the correct way?
Like I'm not sure if you would need to subtract. So while you're doing traversal, you're adding seconds, and then when you realize the path doesn't exist, you're subtracting seconds.
Mm.
Is that what you're doing?
So yeah, but you say maybe there's no need to add seconds before I actually find like a apple. Hmm.
Let me think.
But if I check like for this, like if three had an apple on this subtree, then say I was exploring this, I would go to two, and two didn't have an apple. I wouldn't like add any seconds. Then I'd go left, and then I realize, oh yeah, it does have an apple. So I would need to keep track of the
Yeah,
number of nodes I visited, number of edges I like traversed.
yeah. Okay. Try to think of a post order solution to this.
Oh, post order. Okay. Hmm. So I'll check the left subtree, and I would like conditionally write. Like I would do like a recursive. recursive post order. So I like check the left subtree, and if it actually if it returns something, like I don't know how many apples it visited, then I would add the time. But if like I check the right subtree and there were no apples in there, then I wouldn't even add anything to the time. Right?
Mm-hmm.
Yeah, I think that could work. But I would just check if a particular subtree during that reversal I like encountered any apples.
And
And then based on that, I would add the time it took to traverse it to the result. But
okay.
if there were no apples, I would not add it.
Yeah, how would that work on this small case right here?
Okay. So I'm at node 0. I would recursively call my like function on the left subtree. And I will check one. One is apple.
Sure.
So I would return how many seconds I spent finding all the apples in there. So it would be P1. And then okay. I also need to account for the time going back. Mm-hmm.
So pretend this was marked. Would it change anything?
No,
It would change the answer? No.
I don't think so. Yeah, it would still be 2 seconds for this small example. Yeah.
Okay, let's try a different question. Let's move on to the next one.
Yeah, okay.
Here, I'll post
Uh,
I'll
yeah,
post in I'll post in the next
struggling.
question. So we're gonna move on to Q2 just to make sure we get through all the questions, but we're gonna be given two strings, S1 and S2. Find out if they only differ by the insertion of a phrase. So for example, this one should return true. This one should return true because they differ like cute little. If you add
Mm-hmm.
that into T or S2, they equal the same phrase. Does that make sense?
Yeah. So by phrase, you mean just some sequence of words
Yeah,
separated by
exactly.
space?
Exactly.
Okay. Yeah. So I probably could. Okay. Let me just look at the second example. So we have the boy is nice, the girl is nice. So since this phrase doesn't have a boy in it, then it's not. So, but if I had a boy in here, then it would be true, right? Like for the second string, if I had a boy,
If you had where?
like here. Oh, you see it?
Yeah, then it would be the same because if you add girl there, but right
Okay.
now that returns false because there's no way you could make the two strings the same.
Okay, makes sense. So I could probably split the string by a space to just get all the words. If I like tried on this example, uh, I'll get like the boy goes to hospital.
Hmm.
I like basically the same thing. It's a cute girl. Okay. So say iterate over this longer array. You have like 2 pointers. Like say they all start at the first word.
Yep.
I would compare the words. If they're equal, then I can like move both.
Yep.
If they're not equal, I'm supposed to. So I, and the phrase is inserted only in one of the strings, right?
Yeah, you can insert into any of the. You should be able to insert return true if you can insert a phrase into any of the strings, and then they become equal.
Okay. So that basically means that one of the strings has some additional number of words. So, and the relative order of the like remaining words is supposed to be the same. Then, like, if because I know that this is a longer array, then if they were equal by inserting phrase, like I knew that the phrase was inserted here, right? So I probably could keep moving this pointer until I find a match on the boy. And once they're equal, then and this the phrase that I'm inserting is like it's like how would I say it? So could I have something like this if I had the little boy goes to the youth hospital? This is not valid, right?
What's not valid?
Like this would return false if I had these two words inserted.
Yeah.
Okay, yeah. So I would definitely know by just skipping the pointer in the longer array, I would know for sure that I like skip the phrase. And once I have a matching words, I could just move them. And if I reach the end of that array, I should return true if both points reach the end. Let me try run it on this example. So T boy. Here's the girl. Yeah, in that example, it was easier because this was a longer
Hmm.
sequence of words. So like I knew that if phrase was inserted, it was inserted there. But now it's equal. So I guess I could just arbitrarily pick one. Like let's say the first like remain let's suppose oh I guess if they have the same length, then the strings have to be equal. Yeah. So if I split both strings by space, they are the same length, then I would just check if the two original strings are equal, right?
Mm-hmm.
Because yeah, I can't think of any other ways I could insert a phrase. Yeah. So I don't even need to deal with this example, with this case. So I would just check if two strings are not linearly equal, I'll just return false in the case of equal number of words. Okay. Yeah. Um. Yeah. Can I start like
So,
implementing?
wait, what's your solution?
Yeah. So I first split the words by space, get like two arrays. Uh, then I would handle first like this case. I would check if their lengths are equal. If the lengths
Okay.
are equal, I will return whether the original two strings are equal.
Okay.
Otherwise, I would initialize two pointers, both at the start. And if the words are equal, I move both pointers. If they're not, I would move the pointer like of the longer array. Because I know that we should have inserted the phrase there.
Okay. And like,
Yeah.
what do we mean move the pointer? So if this is
Yeah,
gonna,
so like
yeah, can you explain that?
yeah, so we have like cute and boy here. Uh I would keep moving cute until I found a match on a boy. Once I have a match, I continue doing it. But if there was no match, I would just return it. Like if I reach the end of the array, I would return false
Okay. So what
because this word
happens?
is never matched.
What happens if? What happens if? Um, like once we've matched boy, what? Like, can you continue out? What happens with the algorithm?
Yeah. So if we match boy, our pointers are here, like at the second position, fourth. I'll just move both again. Or maybe there is. Yeah, I think I would still keep checking the other words. Even though I can insert only one phrase, I still have to make sure that the rest of the words are equal,
What
right?
happens? What happens if this
If this
S one
was
is
like,
S2 is has extra Z there?
yeah, so I would keep moving this.
Or why would we keep moving?
Then because so the second string, like the second array is longer, so if there was a phrase, it would be there, right? And so I could just move all the pointer to skip all the words that were in that would have been in the phrase.
Wait, say it
And
again.
I would have moved. I can move the pointer if there is no match because if the phrase was in some like if the S1 and S2 only differed by a phrase, like the phrase must have been inserted in the longer string, no longer um, array
Mm.
of words. So my pointer for the first string remains here, and this one just keeps going until there is a match. But none of them give a match to goes. So I reach the end of the array and return false.
Well, what if this was goes? I'm not understanding the logic. Like,
If
what if
this
this
was
was
go,
goes? Then do we actually want to match on that?
so oh, okay. So if this was yeah, I see what you're saying. So that would mean like there was like a second phrase in between because Once, okay, if I like my like if my logic remains the same, I keep moving my pointer, and I have a match on boy, then I can move both, and the rest of them have to be the same. Like all the words after the pointers. Is that right?
Yeah.
Okay. Yeah, that makes sense because my solution didn't account like having a second phrase.
Like the phrase needs to be inserted in the contiguous. It's a contiguous phrase. We can't insert a bunch of elements in between different words.
Yeah. Yeah, I didn't account for that. Okay. So yeah. So if once I once I'm done moving the pointer and I get my first match on the boy, I'll just check the remaining words. So it'll be like goes to the hospital and like goes Z goes to the hospital. I'll compare the two arrays. If they're equal, I return true. If they're not, I return false. Yeah. Can I start implementing or am I still missing some edge cases?
I mean, what if there's boy here? Does this is this should this return true or false?
Yeah, that should return true because I have a cute little boy goes C phrase. Mhm. Mm. Yeah, even though I matched on the first boy, that doesn't mean
Mm-hmm.
that this boy wasn't like a part of the phrase.
Mm-hmm.
So
Okay, I'll give you a hint. What happens? Okay, we have we have the two pointers. We see boy and cute.
mhm.
They have a mismatch, right? Is there a way
Yeah,
to move up the pointer in like move up the pointer in a smart way so that like where should we move this pointer up to ideally?
which boy? Like the second one?
Yeah,
Where we should move it?
where should we move it? Is there a way to figure out where it should move to?
Like to the last appearance of boy.
Is there any other place that we should put it besides the actual content of the word?
Besides what?
It's like where would this pointer need to go in order because this boy needs to match, right?
Yeah.
So we can look for the next boy and that could work or but then I just showed you a case where it wouldn't work.
Yeah, yeah.
Is there
And
under any other way we can move up the pointer?
yeah, I was saying like to the last boy we encounter. So like this boy.
The last boy that we what if there's
Yeah, like
multiple what if there's even another one after that? So we just find that what if there's a boy over like the word boy over here? We just move to the last one.
Yeah, if we move it here, then but then they wouldn't match, right? Like this would return false. Yeah, and
Okay, so we had a mismatch on boy and cute. Now we need to
mhm.
match the last one, two, three, four, five elements of the top string, of the shorter string.
Yeah. Oh, so the last five of this thing have to match.
Yeah. So is there a way that we can move up the index in a like where would we move the index up to?
Like length minus five. So we'd yeah, we'd like go here to this boy. Okay. But then how do I know? Like you said, the five supposed to match. Oh no. Yeah, they will have to. Because once we have a mismatch, that means the phrase, like all the words will be part of the phrase. So the last have to match. Okay. So once there is a mismatch, we would see how many words are remaining in the first array and just check the last this number of words at the end of the second array.
Mm-hmm.
Yeah.
Okay. Go ahead and try to implement that quickly.
Okay. Uh, do I wrap it in like a function?
Yeah. Come up with like a function that takes in two strings and returns a boolean.
Okay. So I split them first on like a space. I have like two pointers. J. If so, if length array one equals to length of the array two, this is this case. Then I'll just return whether S1 was equal to S2. Otherwise, so I have to have my loop, and while I is less than length of. Yeah, I first find like the which length. Yeah, I could trade over the max of the lengths. No, max of length. One. If there is a match for array one equals array two J, I move both. Otherwise, so here,
So while I is less than the max, could we run into a null pointer exception with this code?
uh, yeah. So it's probably better to do min. They're not equal. I still need. Okay, yeah. So I'll have to check if array is equal to the last. Yeah, I need to know which one is bigger. So kind of like a Boolean is first longer. So it's, the first is longer and I have a mismatch. I'll check if. Sure.
I'll give you one small hint to just simplify. Is if
Yeah.
you just look for, like, if you notice one is smaller than the other, you
Mm-hmm.
could swap them. You could swap the variables so that you could this while loop is consistent, is uniform, so you don't have to add two cases. Make
Oh,
sense?
okay. Swap them.
Or like up here, if one is longer than the other, pretend you expected the first to be shorter than the other, then the second, you just
Oh,
swap
okay.
them.
So if the first one is bigger than the second one, I'll just make the first. It's like something like this.
Yeah, something like that.
So now I know that the second one is always bigger.
Yeah, just to
I would
simplify
check.
it.
Yeah. So I would check if array uh if array one starting at index I equals to the last. So it'd be like array two length of array two minus. Oh, it's messy. So this gives me how many words are remaining. And then I guess the last remaining words from array two will be length of array two minus. Just making sure this is correct. Minus one. Here.
Okay, sounds good. All right, we're pretty much at time. How do you think you did? How was it?
Uh, yeah, I didn't do that good. The first question, I was trying to, I guess, think of like a efficient solution. And then I started thinking of brute force, but like I couldn't think of any good ideas.
Mm-hmm.
And for the second question, I like had an idea and then I got stuck with it. And I thought it would be correct. I should have like tried counterexamples on my own.
Yeah. Let's
Yeah.
let's walk through the first question real quick. So the first question was coming to the drawing is related to the tree question. So the way to
Yeah.
solve this one is a post order traversal.
Okay.
So pretty much, if you've seen an apple,
Mhm.
you should return one. The way I solve this is, if you've seen an apple during your traversal, you should return one.
Okay.
So for example, this one, we do a post order traversal. So we go down this way, then we go down this way, then we go. So we hit null. So since these are null, we return zero, and they didn't see an apple, right?
Mhm.
So for four, 4 we seen an apple, so we'll return 1. So 1 is on this side. 5 we seen an apple, so we'll return 1. So this one it's seen it gets 2, and you pretty much just have to multiply by 2 because you have to go down and come back up, right?
Oh,
And then
yeah.
this one we know we seen an apple because maybe we passed up a boolean. So we just add 1 plus 1 plus 1 because we're going back. So this will get 3.
Okay.
And then like this will return 0 here, 0 because it didn't see any apples. And then you
Mm-hmm.
go 3 times 2 equals 6. So you could solve that one with a post order traversal.
Yeah.
Yeah. It's a bit
And now
tricky.
look at the solution that makes more sense.
Yeah, you should try that one. I think it seemed like you do know how to you knew the different options such as pre-order, in order, post order. But I think just practice a bit more in the post order traversals. There's a lot of questions that you could solve with a post order traversal. So
Okay.
I'll probably send you a list of good, or let me see what are some good ones.
Yeah, that would be nice.
There's some good questions, and a lot of them like by diameter of a binary tree. That's a good one for post order.
Mm-hmm.
And just practice a bit on some post order traversals, and try this one out yourself, and I'm sure it'll help a lot. Second one, yeah, I think you understood how to use pointers, but then you were just getting confused on the solution. So you wanted to I think you had some good insights, but you just couldn't iterate to something that worked. So I think probably just
Yeah.
taking a step back, working through smaller examples, and just working through the examples and making sure that you understand and have a good solution before you implement it. Because a few times you were asking if you could implement it, but you didn't have the correct solution yet. So I think even with the first question, working through a smaller example would have helped a little bit more instead of
Okay.
working through the big question. But yeah, I think you understood the pointers, but it was just iterating to solution. You just didn't get there. So I think you have solid foundation. It's more just getting the reps in and getting more practice. But
Yeah.
yeah,
It's like so hard to think when you have to like constantly talk.
yeah,
Yeah, it's very hard. I have to practice more, definitely.
yeah. Go try that. Try this one is kind of try. Have you tried Valid Palindrome 2? Valid Palindrome 2?
Uh, I don't think so.
Yeah, try Valid Palindrome 2, and then try Diameter Binary Tree. And yeah, you
Okay.
should schedule again soon. I think try in a couple weeks, you're gonna be a lot better. I think all the fundamentals are there. It's just iterating through solutions and coming up with something simple.
Yeah, yeah, that makes sense. Do you have any other, like maybe the way I was articulating ideas or like going
Yeah,
through
honestly,
examples?
the no comments on nothing bad about how you articulated. I knew exactly what you were thinking. That's why I was able to
Okay.
give you suggestions. And you're going
Okay.
an approach that sort of made sense. Like I could see why you went that approach. It wasn't completely random. But then
Mm-hmm.
those approaches would have fell flat. So it's just figuring out why they would fall flat and how you could fix that approach to make sure that the solution worked.
Okay. Yeah, that makes sense. Thank you so much.
Yeah,
I
no
think it
problem.
definitely helped me.
Yeah. Good
Yeah.
luck.
Yeah, thank you.
Yeah, but book again. Let's see where you're at in a couple weeks.
Okay, yeah, for
All
sure.
right, good luck, man. See
All
ya.
right, thank you.
Bye.
Yeah, have a good one.
You too.